Hey everyone, welcome back. We have mastered variables, functions, control flow, and borrowing. Now it's time to level up and create our own custom data types with structs. This is where we will start building complex real-world applications in Rust. Structs are the building blocks of Rust programs. They let us group related data together and define behavior with methods just like classes in other languages, but with Rust signature safety guarantees. So in sequence to this, our today's agenda would be the struct fundamentals, followed by the creating instances and field access. Then we will implement methods with impl keyword and we will discuss the associated functions. Later on, we will check out the tuple structs and unit structs, and eventually we will discuss the real-world struct patterns. So let's dive into it. To define a struct, the syntax goes like this. First of all, we have to write the struct keyword and then the name of our struct. In our example, I'm using the name as user. Then inside the curly braces, you have to specify the properties that you want to keep into your user named struct. So for example, my first property here would be username, which will be of type string. Second, it would be email, same as the type string. Third, the sign in count, it would be type of U64. And lastly, the active attribute, which will be of type boolean. So I want these four attributes to be part of the user struct. Then I will declare the main function and will create an instance of this struct. So let me create the instance here. Let user1 is equal to user, open the curly braces and provide the values to each of the attributes. So for the email, give any random string, whatever you like. So I am here choosing the alice@example.com. Afterwards, I will specify for the username attribute, and for that, I will give the Alice username Alice123 and active as true, and sign in count is equal to 1. So with this way our user1 instance is created now. Put the semicolon to complete this. Then check with the printing user curly braces user1 dot username. Similarly check for the other attributes as well. Email user1 dot email active, and lastly the sign in counts. Sign in count. Let's compile this. Struct example.rs. Struct example. Struct.exe. These are the values that we have provided. However, note that this user1 instance is actually the immutable, and after this initialization, if you try to update the value of any of these attributes, then Rust will throw error on this. If you want to create a mutable instance, then you have to specify the mut keyword just before the uh, name of the instance. For example, if I have to make the user1 as mutable, then I will write as let mut user1, and the further syntaxes would be same as before. For updating any of the attributes, you have to for example, if I have to update the sign-in count, then I will firstly write the instance name, then the dot operator, followed by the attribute name. And with the use of is equal to operator, you can up provide the updated value for this attribute. Let's update active attribute as well as false. Finally, you can check them by printing their updated values. Updated active, updated sign. So our updation done here is now reflecting in the terminal. This is how you can create instances and update the any of the attributes. Always remember that whenever you specify the attributes, you have to specify their types as well along with it. And for accessing these attributes, you have to use the dot operators as I have done here. And for the provide creating the mutable instance, use the mut keyword. This is how the structs work. Luckily, there are other shorthand syntaxes as well through which you can create and update the instances with fewer line of codes. So to illustrate you, let me do a little updations here. For example, I'm creating a function named as build user, which will take email as an parameter, string, and then the username, and it should return the user struct. And inside this, I would be returning a new instance of the user struct having the email same as that of the parameter in the function, and the username same as the parameter of this build user function. And for the active, I can provide my custom values here, and sign in count. For sign in count as well, I can provide custom value. Then I can use this build user to get the a new user struct instance. For that, let user3 is equal to build user. Inside this, field user string from charlie@example.com, and the username charlie123. So with this, I will get a new instance with these attributes, and it will be stored in the user3. Rust also empowers you to create a new instance of your existing struct type using the existing instance of the same struct type. So, for example, if I want to create a new instance named as user for, in which I want to keep some of the attributes of the user3, and for the rest of the properties, I will provide the newer values. So to do so, you can proceed like this: user, and for example, for the email, for example, this Charlie user want to their email to be updated as charlie.john, and for the rest of the attributes, it want their the existing values same as is stored in this. So for that, you have to use this syntax double dot and user3, because I want the rest of the user3 properties to be used in the user4, and just for the email I want the updated values to be reflected. So with this you can create new struct instances with the shorthand syntaxes. Rust also empowers you to specify methods in your structs to provide some behavioral aspect onto your struct instances. So to uh, create the methods for your struct instances, you have to go with the impl keyword. After the impl keyword, provide the your struct name onto which you are going to create the method. So impl user, inside this you should define your functions which will actually work as methods for your user structs. So fn, and let me create a method name as update username, and each of your methods take a parameter named as self. Self actually is the reference borrowed onto the instance who is calling this method. So ampersand self, and to actually update the username, you have to take the new username as a parameter. So new name, which will be of type string, and let's say it returns a new string. Also, the reference should be mutable one, because an immutable reference is not capable of updating the values. For updating values through the references, you have to declare it as a mutable reference. So inside this, write as self dot username is equal to new name. And afterwards, I want to provide a message that username updated. So afterwards, uh, give a message that updated username dot to string. So after the execution, this will be returned via this update username method. And let's now update the username of the user1 instance. For that, define let message user1 dot and call the update username. Inside this, provide the new username, which I suppose can Alice239 as the new value. Call the toString method and then check whether the username is updated or not. Updated username user1 dot username. Comment these printlns for better clarity. Rust example.rs. So updated username is Alice239, which is same as the our provided parameter Alice239 here. So this is how you can define the methods in the structs. Rust also empowers us to create static methods in our structs, and those are called as the associated functions in the Rust terminology. These associated functions are not called by the individual instances, but rather you can call them using the struct types directly. So for that, for that associated functions, they do not take this self parameter, although you can provide the various other parameters that you want it to be take and do some processing. But uh, as a syntax point of view, they do not take any self parameter, and also they are not associated with the individual instances. Their syntaxes go like this: fn, for example, new user, the name of the associated function, and inside this, uh, suppose I write the email string name string and return a new user. Inside this, a new user instance would be returned. Whoever new user, whoever will call this new user. Inside this, you can keep the username as the name, whichever it came via the parameter, and then email as email, and then the custom values for your rest of the attributes like active, true, and signing count as 1. So this becomes the associated function with this user count. struct, and to call this you must follow this syntax. Let a new user is equal to user double colon and the new user method. New user, yeah, the cases are fine. And then you can provide the new emails abc@email.com dot toString abc dot toString, and then you can check by printing them. So associated function significance is usually associated where we want to write some utilities functions which are generally associated with the original struct rather than the to any individual instance. And suppose you have to count that how many instances uh, is has been created of that struct, so you can write the corresponding utility function with this associated function feature of the rest. For following the factory design pattern as well, this associated function will prove very useful. Hence, you must decide based on your requirements that whether you actually need the associated function in your Rust code base or not. Let's now discuss the variations of the structs that are offered by the Rust. Those are tuple structs and unit struct. So the tuple struct is actually a variation of a struct that allows you to define a named type with fields, but unlike a traditional struct, instead you define the fields by specifying only their data types within parentheses, similar to how a tuple is defined. The syntax for tuple struct goes like this: the struct keyword, then the name of the struct, and inside the parenthesis, you provide the data types for each of the fields that are going to be part of this color struct. Similarly, for the point struct here, where every fields will be of the F64 data type. A tuple struct gives a name to a collection of data, making it a distinct type in our program, as I have created in my code here, color and points. So this feature allows the user to actually be concerned with the name of the entire collection rather than concerning with the names of the individual fields. So that's why the significance of tuple structs becomes more strengthened. So how should you must use this tuple struct efficiently? Let me show you by the code snippet. So I'm first of all created the color and point tuple structs and defined the instances of these tuple structs. Black is corresponding the collection of 000 and white is representing the tuple collection of 255, 255, 255. And lastly, the origin instance is actually referring to the origin in the 3D coordinate geometry. So to access the values of these individual fields, you have to use the dot operator and provide the index names, because here we do not have the fields name. So that's why for accessing the individual values, you have to use the indexes here. For example, for this black instance, it's a individual fields you can access through this, and for the origin, you can similarly follow along like this. If you have to destructure this tuple structs, then you can follow like this. You can must define a new uh, instance like color RGB, and you must use the your existing struct to destructure from, like here the white instance has been used, and later you can print each of these RGB values to find out whether it has been accessed successfully or not. This is an example of a tuple struct with the single fields existing in that. So that's how the tuple structs works. Next, I'm going to show you the unit structs. Let me create new file first. So in reality, unit struct do not hold any data. When we define it, we actually do not provide any field names to it. We just use the struct keyword and then our struct name, and lastly we put the semicolon. That's how the unit struct is defined. And unit structs do not store any data within themselves. They are just a distinct type that carries no information beyond its own existence. And since they do not hold any data, they are just zero-sized types, and they do not occupy any memory at runtime. To illustrate you with an example, so here I have created the three unit structs named as marker, click event, and network request. And marker struct is provided a method here, identify named, which will print that this is a marker, and process event function to show the user that some processing is happening after he has clicked on something. The initialization goes like this: let marker is equal to marker and semicolon. Since it is not having any fields, there is no requirement of giving the parenthesis. For the calling of the methods, you must follow the same syntax as before, and you can print the size of these markers following this syntax. It would just print 0 because they do not hold any memory. This is how the tuple structs and unit structs works in the Rust, and both of them holds significance in the Rust universe. Let me give you a much more practical example where you can use struct to serve both your requirements and hold the security concerns as well. So this is a code snippet for management of the bank account. So in the domain of managing bank account, you must have a method for creating new account, and you must have a method for depositing some amounts in your existing account, and you must have a method for withdrawing amount from your existing account, for which there is a logical method named as withdraw here. And for the check balance functionality, the get balance or the view balance like method you can deploy into your code base. And for getting the information of your account, like account name or the uh, account type and when it was created, like these metadata you can occupy with the getinfo method. For deactivating or deleting the account, you must have a separate method. In this case, the deactivate method is kept here. And for transferring the between accounts, uh, there is a method named as here fn transfer. This method helps the transaction from one account to another account, and you can then give the proper values on to these methods and these fields so that you can check how it is working. For example, I have created here a new account whose name and ID goes like this. Similarly, second account whose owner is Bob Johnson. And later I have performed some operation onto this like depositing the 1000 into the account 1. If this was successful, I would get deposit successful, or otherwise I will get the message as default or deposit failed. And for checking the my current balance in the account 1, then I can call the get balance method on the account 1. If you have to check for the account 2, you just have to provide account 2 here. And later for the withdrawing money, I have used here match expression to check that whether uh, the 200 withdrawal from account 1 is going to be successful or not. If it was successful, I get the message that I have withdrawn the corresponding amount. Otherwise, I will get a message that withdrawal failed. And lastly, I will get the account 1 balance after the withdrawal. In case of money transfer from account 1 to account 2, I have gone like this, and I have handled the failure and success like this. After the transferring, I have then printed the values or say the current balance in both the account 1 and account 2, which I can get from the get balance method. And lastly, I have checked with the metadata of that accounts with the get info method. This is how you can set up your bank account use case with the struct feature of the REST. In these use cases, mutable and immutable reference will hold very high importance, like self. For the depositing, you must have a mutable reference for updating the amounts in the current account, or when you need to only view the current balance or the metadata of the account, you must have the uh, immutable reference for the security concern. Like this, for the get balance, the immutable reference is used here. Let's summarize the important best practices associated with the struct usage. First is that group your related data and follow the single responsibility principle in your structs and use the methods for the behavior aspect on your instances. Keep data and behavior together and prefer the immutability when you want your fields to be readable. Uh, Provide the mutability only in that case when you have to mandatorily update those fields. Otherwise, avoid providing mutable references on those fields which you want to be immutable, and use the associated functions for constructors and utility functions. And lastly, choose the meaningful names on your structs and field names so that it can become clear whenever you look on your code base, and you can easily retrieve the meaningful logic behind those names, and also you can associate them with your use cases. So that was all about today's video. As an homework, you can create a student struct with fields for name, age, and grades, and implement methods to calculate average grade and adding new grades and determine if the student is passing or not. This will provide you an observation that how you can create or manage your student application where you can manage the students' grades and their performance with the Rust features. In our next video, we will explore enums and pattern matching in depth. Enums are incredibly powerful in Rust. They can store data and work beautifully with batch expressions. You should not miss it. Stay tuned for that. If you have any questions about structs or want feedback on your homework, drop them in the comments. Like and subscribe if you are enjoying building real Rust applications, and I will see you in the next video. Thank you.